Hello everyone. Now we are good to start with machine learning model building for sentiment analysis, right? So we have covered most of the prerequisites which are required for NLP, right? As we know, the first step would be the data collection, right? And once we collect the data, so we have to do a lot of the data preprocessing, and then we need to try with different machine learning algorithms, and of course we need to select the best model out of the different algorithms which we tried. In this video, we'll talk about data preprocessing, and in the next video, we'll talk about the model building and the best model selection. Now we'll try to explore the data, right? So I already have the data which I downloaded from Kaggle. Maybe let me zoom a little bit. Yeah. Right. So now, what are the preprocessing steps we need to do? We obviously have to remove some special characters like this double quotation, dot, maybe some dollar symbols, etc., right? In case if we have any emojis, maybe yeah, something like this, we need to convert back into the normal form. We know the meaning of this, right? The person is happy, so maybe we'll make it smile, right? And one more thing which you see is sad. We'll convert this emoji as a sad. And when you talk about any mentions, right? Let's say if you see any value that starts with at the rate, like we are mentioning someone, right? So this particular value mentions won't make any sense for our analysis. So what we'll do is, so any value that starts with at the rate, we'll remove that, right? And of course convert all the data to lowercase. Maybe for example, when you talk about flying, the word flying, the F starts with small or F start with capital letter, gives it the same meaning, right? So it's good if we convert all the values to small letters. And then obviously we need to remove the stop words, right? That really won't make any sense. And then we need to tokenize the data, right? And then we can go for lemmatization. In case if you're not sure what is stop words, word tokens, lemmatization, I made a videos for this. Please make sure you watch that, because this is the prerequisite for NLP, especially in data preprocessing. So now we'll import the required packages. Okay. Yep. Now let me try to read the data. Data set equal to, we know, pd.readcsv. And my file is in this location. Now let me try to read this data. Oh, I need to run the pandas. Yeah. Now if I open this data frame, as usual I have two columns. One is sentiments, which is with the negative or positive. The other one is the actual test. Now on this we need to do data preprocessing, right? Now as usual, the first step which we'll do is removing the emojis, right? So what we need to do is we need to create some dictionary, something like this, right? So if we have this value, then it is smile, right? And we have different emojis, right? So when you see this kind of emojis, it is nothing but angel, right? So yep. Now let's write a function for cleaning the data. That will take data as an parameter, right? So I'll say data equal to, first I'm converting everything into lowercase, right? And then the one step which we discussed is remove the remove the word which starts with at the rate symbol, right? The mentions. So we'll write some simple regular expression, data equal to re dot sub at the rate slash yes plus. So if I find this value, then what I'm saying is replace with the empty value on my data. I also need to import the regular expression. Now we'll deal with the emojis. For emoji in emojis dot keys, because that's a dictionary, right? Now data equal to data dot, I can use a function called replace in string emoji, this emoji, which means like every time we'll get one value, right? And then this emoji of this. So simple. What I'm trying to say is, boss, if you find this emoji, I mean this particular emoji, then replace with this particular value, right? Now I came out from the loop. Now we can remove if there are any tabs, extra lines, right? Come on, data equal to re.sub /s plus, if I have any tabs, 5 spaces, 6 spaces, any extra spaces, I'm just saying replace with a single space, right? And then what I'm doing is, now I'm just taking only letters, which means like we have some special characters. See, the reason why I'm taking letters now is, see, when you talk about this, is definitely special characters. Now before I'm taking letters, I'm just dealing with this kind of special characters, nothing but emojis, right? And we also have few other special characters like double quotation, dot, right? Now we are just trying to remove it. We can remove the special characters before this emoji. What happens then, we may lose this valuable information. That's why first we are converting this emoji special characters into the text, and now we are removing the other special characters, like as I said, comma, double quotation, dot, colon, etc, etc, right? So now we are taking letters using again the regular expression. So regular expressions are actually, awesome. We can create wonders in regular expression, right? Did you see, like with this simple string, we are just able to remove any word that starts with at the rate with this simple this mention, right? Small a to small z and capital A to capital Z. We are just taking only numbers, sorry, the characters, nothing else, right? Come on, what happened? Yep, come on, data. Now what I'm doing is, I'm just maybe what we'll do is, this lemmatization and stop words will do the pandas level, right? We'll do the basic, the data preprocessing in this function. Now we are good to return the data, right? So now we create a function. What it does is, it will convert all your data into lowercase, right? Remove any mentions or any words that starts with at the rate. We are converting these emojis into the actual meaningful word, like smile, angel, confused, something like that, right? And then we are removing this special lines, extra lines, if you have any extra spaces, I'm sorry. And then we are taking only the letters. I think we also need to do one more thing. So we are removing the extra spaces. We should also remove if you have any extra lines, right? Yeah, here we go. I don't think we need plus here, right? And then what we are doing is, we are returning this the preprocessed data set, right? Okay, before we go to the pandas, what we'll do is, we'll try to create one more function that take care of removing the stop words. right, which will take the words, right. Maybe I'll, what happened, yeah, I'll create an empty list. What's wrong? Okay, for W in words, what we need to do is, okay, my bad. So before that, we need to import one important package called NLTK. That is one of the best package where you can think of when you want to implement NLP. You can think of NLTK, right? So we have a corpus. Oops, my bad. In NLTK we have COUR, CORP. Oh man, I'm really bad at spellings. So in the corpus, what we need to do is we need to import the stopwords. Stop, WORDS. Let's try to run this. Array, come on, from NLTK. Yes. Now we imported the stopwords. Yeah, let me put it here. I'll say stop words is equal to, if you let me run this so that we'll get some idea, right? This is a function, so we'll say stop words dot word. I want English, ENGLISH. What happened? Yeah, I need to close. Yeah, now these are the stop words, right, which by default we'll get from NLTK. So this is, you see this, right? This is technically a list, right? So if you want to add any new stop words, or if you don't want the stop words, let's say if I don't want to remove a stop word hour, because for my analysis it makes sense, in that case I can simply remove this word from this list. Or else if I want to add any stop word, we know this is a list, right? We'll say dot append and we can add what are the value we want, right? Now you know what to do, right? So stop words dot words English. Yeah, now we have a list, right? Now what we can do is, now we'll check. So this is the words which we are getting, right? Now I'm checking this word is available in my actual data or not, right? We'll try to understand. No worries, right? So now, so I said for W in words, which is this one, which is our text, our each line of the tweet, right? I mean, let me make it more clear. Now, and this I'm looping, right? And now I'll take each word from this, like it's really aggressive, right? And I'll check if this value is available present in the list which we just created, right? The list for the stop words, this one, right? Now if W not in stop words, then we are adding that word in our list, the empty list we just created, right? Let's say if that particular word is available in our stop words, then obviously we don't need it, right? And then now I can return my filtered words, right? Now the actual steps, right? So now in this data frame, what we need to do, so we need to first clean the data and then we need to remove the data. We also have one more step which is called lemmatization, right? Which now we are going to do it. Now first we'll clean the data, right? So this is our data set, data frame. So obviously we have two columns, one is sentiment, another is text. Text is the place column where I have the actual data. Obviously I need to perform this cleaning, removing the start ports, whatnot, right? So on top of that text, right? Text column. Now in pandas we have an awesome function called apply, right? Lambda x. So now the clean data of x. Okay, it says it's not defined. Let me run this. Okay, I also need to run this dictionary. Now let me run this. Yeah, now let me open this Twitter dataset. Did you see? Now we don't have any special characters. Did you observe this? We have a the emoji. Now we are able to convert to the smile, and we don't have any at the rate any words that starts with at the rate, and all the letters are small, right? So we're able to remove the special characters and everything, right? So now what we'll do is, now we'll remove the stop words. So we know, right? So when you will see, did you see this? So we are sending a parameter to the stop words as a list. That's why we are able to iterate here, right? Now what we'll do is, now we'll try to split the data, which means we'll try to create a list. We'll try to understand in some time, right? Dot apply x dot split if I have any space. Let me run this. Now if I open this, you'll get a list. Did you see? So wherever there is a space, it will create as a new word, right? Which becomes a list now. Now I can call my split function. Now I'll comment it as removing stop words. Instead of this, I'll say stop words. Maybe before I run it, let me open this and we'll see this data one more time. So if you see, we have 8 in the first row, in the second row we have and 8, right? Now maybe let me try to run this and see how it looks like. No, this is not the right way. We just copied from the above line, right? So should be x. Now let me open this data set. Come on. Yeah, did you see? Now we don't have and 8, which we just seen before, right? Because now we successfully removed the stop words. And now what's next? Obviously, so we clean the data, we remove the stop words, and the next step would be the lemmatization, right? So now let's import it. It will be nltk dot, we have stem, and inside that we have word lemmatization. Now obviously, even for lemmatization, we still need a list, right? So not removing, we can say stemming or lemmatization, right? So we already imported the required package. Now so I initiate an object for the word lemmatization. Now obviously I need to perform this on my text column. Dot apply, right? So I'll say lambda x is, now we need to, this is my object, right? And this lemmatize. What I need to lemmatize? I need to lematize the word Now what is this word? Because this is the list comprehensive, right? For word in X, right? This is my X. So what we'll have is we'll have each row in the X, which is nothing but let me open this data set. Yeah, for each row we'll have it, right? And in the each row, this is a list again. So that's why again we are iterating it for word in X, right? So we have let's try to see the data. We have really, aggressive, blast. We have guys here. Let me run this and open it again and see how it looks like. It says invalid syntax. Let's check out. Yeah, this comma. This is yeah. Now let me run this. It says like, okay, maybe I need to run this. It's running. Yeah. Now let me open our data set and see how it looks like. We have guys, right? Before it now it make it to guy, right? So there are few words, right, which it converted to the root word, right? Now obviously now this is a list, right? So we need to convert it back to the text. We know how to do that. So we know what split does. Split will convert a string to a list. Now if I want to convert the list back to a string, we have a function called join, right? Lambda x colon dot join of x. Well, let me open this now. Yeah, now we got the string, right? Now we are good with the basic data preprocessing, right? So what we did, so we removed the special characters, we removed the mentions, right? So we removed the space, extra spaces, we removed the new lines, right? We convert every word into lowercase, right? And then we removed the stop words, right? So we converted all the words in using lemmatization to its root form, right? So we are done with the basic the data preprocessing steps. So in the next video what we'll do is, so now obviously this is a text. We know none of the machine learning algorithm will understand the text, right? Most all the machine learning algorithms will understand in numerical format, and it should be a structure, right? So we already discussed what is the count vector, right, or backup words, and we also discussed what is TF-IDF, which is term frequency and inverse document frequency, right? So now in the next video what we'll do is we'll try to convert this unstructured data into some meaningful format using TF-IDF, like I mean the structured format using TF-IDF, right? So in case if you're not sure what is TF-IDF, I made a video. Please make sure you watch it before you watch this video, the next video, right? So and then what we'll do is we'll pass that data into different machine learning algorithms. We'll try to find the best algorithms out of it, right? So hope you enjoyed this video. So till then, please don't forget to subscribe to my channel. Thank you.